Okay, so a little bit more complicated centripetal force problem I thought of last night. We went down to iDrive last night, and my children did the one swing thing where it goes up in the air and spins around in a circle. This one. I don't do video editing, so it's just this one where, yeah, they were very excited. I think they're broken people. Like that one, like they're not. That's not okay. They did it a couple of times. They did it once early and then once after dinner. Anyway, I had a realization that we could calculate how fast they're going because when it was spinning, it was right about a 45-degree angle. And if that's about a 45-degree angle, then there are some assumptions we can make. We know their weight downward. And in fact, I can just make it up. I'm just going to make up 200 newtons. That's not right, but I'm just going to make it up because the mass cancels out anyway in the problem, right? We could actually figure out exactly what they weigh and what the cart weighs and all, but the mass is going to cancel out, so it won't matter. So I'm just going to say they weigh 200 newtons, which is about 50 pounds, so nowhere near accurate. But if they're at a 45-degree angle, that means 200 newtons down, 200 newtons out also, right? If they're 200 newtons, that's 20 kilograms. Let's just go ahead and go 2,000 then, right? I don't know why I said 200. It's not going to matter because the mass is going to cancel out. But let's say 2,000. So that means 2,000 newtons down, 2,000 newtons out. Because if they're at a 45-degree angle, the force down is equal to the force out, right? Or the force back in, right? Because that's keeping them in. They've got inertia that's trying to go in a straight line. That means they're trying to come back in, right? So if we have 2,000 newtons of weight coming downward, we have 2,000 newtons of centripetal force pulling inward. So my centripetal force is 2,000 newtons. I want to know how fast they're going. I don't want to know in some radians per second thing. That doesn't do me any good. I want to know in like miles per hour or meters per second, right? The sign said they would go up to 60 miles per hour, which would be about 30 meters per second. So I want to know if that's true, right? So if we say the centripetal force is 2,000 newtons, again, because they were at about a 45-degree angle, whatever they weigh is going to balance out with the centripetal force. They'd be the same, right? Same, because they were at 45 degrees. And so then their mass, if they were 2,000 newtons, that's 200 kilograms. Well, in the weight, there's the mass and the weight too, right? So it's going to end up canceling out, so it wouldn't actually end up making a difference. So that's tangential velocity squared over the radius. So when I was standing there, I was kind of estimating, right? And I don't actually have a good radius on that, but I was estimating that it was about 20 meters, right? So I'm going to estimate that that's about 20 meters. So in order to get this tangential velocity by itself, I'm going to take and move this 20 meters over here. So I'm going to say 2,000 times 20 gives me 40,000 newtons equals 200. Excuse me. That's some quality YouTube video right there with me sneezing. 200 kilograms times the tangential velocity squared. Tangential velocity, remember, that just means the straight line velocity, right? If they were going in a straight line, they're meters per second kind of velocity. So to get that by itself, we divide both sides by 200. So we divide that by 200, and that gives us 200. We need newtons divided by kilograms, so that's meters squared per second squared is the unit, and that equals the tangential velocity. So we go 200 divided by, no, not 200 divided by, square root of 200 gives us 14 meters per second equals their tangential velocity, which is about 30 miles per hour. So it said they reach up to 60 miles per hour. I don't think they were going 60 miles per hour because, I estimated the angle here. The mass doesn't matter because there's a mass here and there's a mass in their weight. So that cancels out. So I could put anything in for that and you'd get the same answer. And I estimated this radius and I estimated that it was 45. So I could definitely be wrong on a couple of those things. But according to this, they were in the 30 mile per hour range. But they were also 7 miles up or whatever. Terrifying. I don't know why they did that. Anyway, hopefully that's kind of helpful in a centripetal force problem.